We're going to start again, and I'm handing over to Cassie. Thank you.
All right, thanks, Dwayne. Welcome back, everyone. Hopefully we're able to get something perhaps to drink. Right, so we'll get straight into the second bit, which is this HAZOP planning and preparation, and then we'll also look at the recording and management of actions and all the HAZOP process in general. So I've got I'll take this back into presentation mode. Okay, so you decided by the HAZOP decision matrix or by just by your experience that you need to do a HAZOP for that modification or for that project. The first bit is to determine who you require to be at the HAZOP. So obviously it's a HAZOP. The first person on your list would typically be first yourself if you are the safety engineer, and I'm speaking from the perspective of a safety engineer. So yourself. The process engineer who's responsible for the job, obviously. I think I've listed HAZOP attendees on the next slide. I'll just go to the next slide. I'll take a look. So yeah, HAZOP attendees, you've got to find a chair, a facilitator, an independent facilitator for the to chair the HAZOP. You've got to have a scribe for the HAZOP. So what's been happening sometimes is, sometimes some chairs, some facilitators are very good, very good at multitasking, that they try and do the scribing themselves while also facilitating. It's good if you can do that, but it's actually not recommended because, I mean, no matter how good you are, if you are not you're not listening and trying to run the process and focusing on what the bits that you should be thinking and perhaps asking people to talk about, then you might miss something. In my experience, I've seen quite a few things being missed, when that's done. So you want to have a scribe, a separate scribe doing the scribing, or basically the recording. Obviously, you need to have a responsible process engineer. You also need an independent process engineer. Obviously, with a HAZOP, you are dealing with a process system. So you've got the process engineer that's done the design, so to speak. You also need an independent process engineer to query the design, during the HAZOP. You need an operations personnel from the plant, from the facility that you're HAZOPing. Obviously, yourself, the technical safety engineer. If it's a package, if it's what we call sometimes the black boxes within P&ID, you need the package designer, the vendor, for example, that's responsible for designing that compressor system, that power generation system. That skid, you need them in the room, quite critical, those ones. I mentioned the vendor representative. Within your design, within your engineering team as well, obviously you would have an engineer, be it from the mechanical equipment team, mechanical engineering team that's responsible for that equipment in the sense of, that's the person managing the vendor and looking at the design, them in that HAZOP as well. So those are the core attendees that you need at the HAZOP. So counting from the chairman, you've got 1, 2, 3, 4, 5, 6, 7, 8 people sitting in a room. Typically, you need no more than that. I mean, ideally, really, you need no more than that. Sometimes you need to have the project engineer sit in, especially for the more substantial projects where a HAZOP might require certain, decisions to be made that affect the project's, cost and schedule. So, for example, there's a recommendation, potential recommendation coming up to say, right, we need to add, 3 new PSVs, 2 new valves for this. The project engineer will be thinking, how much do these cost? What's the lead time to get those valves in? Can they fit the project schedule with the delivery times we've got currently, and all those sorts of things? And if he's in the room, or if he or she is in the room, they will be making their inputs to say, because obviously, on what we'll see later on how your HAZOP recommendations should be framed, they have to be realistic within the framework of the entire project. They have to be realistic. So if you are recommending something, a valve or whatever it is that has a lead time of 6 months and your project should have ended in the next 2 months, that's not a realistic recommendation. So it's the project engineer that will be feeding into that sort of discussion at the HAZOP. So sometimes you need them there. It's mostly for the more sort of substantial HAZOPs. You might need other discipline engineers as well. Piping, you might need the piping engineer or the materials engineer, particularly if you're dealing with, certain new kinds of exotic piping systems, for example, and all those sorts of things. You probably need the materials engineer in the room as well, but those are optional and case by case. But on the left there is, you see the core personnel that are required, that you require for the HAZOP. So you want to start off by, determining the required actor. You've identified your chair. Since it's an external person, it's probably going to be an external consultant. You want to go through the procurement processes to get them on board, getting a CTR from them, prepare your your requisition form for your procurement team, and getting all that arranged. You need to be doing that. You identify the date, obviously suitable dates for most people, and the next bit is to then gather your required documentation, the P&IDs. You're checking that the P&IDs are at the required revision status. Typically you want them done, sometimes approved for HAZOP. You want to be using P&IDs that are approved for HAZOP. As I mentioned earlier, sometimes you might be doing, pre-HAZOPs or course HAZOPs. You could use, revision, second revision P&IDs, RO2 for those sorts of things. But for a substantive detailed design HAZOP, you want to be using HAZOP P&IDs that are approved for HAZOP or approved at some stage. Process flow diagrams, operating and safeguarding procedures or philosophies. You need those. Those are quite necessary, I think. You also want to establish and agree the HAZOP notes with the facilitator. We'll touch on HAZOP notes just shortly. You want to agree basically the scope of the HAZOP, what part of the system, starting from where to where are you, and this is talking about a continuous HAZOP as opposed to your batch HAZOP. You want to determine what part of the system the extent of the system that you're HAZOPing. All of this information that you've gathered, you've got the attendees, the dates, and the documentation, the notes. All of that is then used to prepare the terms of reference for the HAZOP, which you should really always have for every HAZOP. Have that issued to the attendees prior to the HAZOP, so they come in knowing what to expect. So that terms of reference would contain things like, obviously, your project description, the scope and the boundaries of the scope and the boundaries of the HAZOP, the meeting arrangements, where are you meeting, for how long, where, the list of people attending the HAZOP, the documentation that's the HAZOP that's available for reference, your P&IDs, any other, the methodology that you're going to be using for the HAZOP. So this is where you say, what it is, what standard. So typically you want to be using the standard of the client's own HAZOP standard. Typically they would have a standard which you would follow. So that typically would go into your methodology. You are doing something a bit out of the routine HAZOP, you want to be saying that. So if it's a batch HAZOP, sometimes it's a combined procedural and continuous HAZOP, you state that's where you put that as well. And then the recording and the method by which you want to record. So are you asking the chairman to come up with a recording template, or are you producing or providing a template? Are you using standard Excel sheets, Word file, or the more high-tech, system applications or tools for recording and all of that? So all of that will be in your terms of reference, which you issue to attendees prior. We talked about HAZOP attendees. Node identification. So I'll say that node identification is not an exact science at all, but there are rules of thumb and some points to consider when you're selecting nodes for your HAZOP. So by definition, really, the nodes are the sections of the plants, the sections of that system the various sections of that system that you want to HAZOP, because particularly, and this is particularly relevant to a continuous HAZOP, it's not feasible really to take the entire system as a whole. Again, depending on the size, it's not feasible to take the entire system and just HAZOP it in one one go. You have to divvy it up into, these discrete sections where you can apply your HAZOP guidelines. And there are rules of thumb for that, of which the first one is that, when you have a change in design intent, so a change in design intent in the sense that that particular bit of the system is doing something different from another part. So you're looking at the air system. I think, bear with me, I think, but I've got drawings that also illustrate that. But I'll talk through this first of all, and then we can look at the drawings. So a change in design intent, for example, you're looking at a system that has an instrument air system, and then a combustion air system. So typically, maybe your what's it called now? Your heater, what is combustion? Getting it mixed up now, but yes, you're either looking at the combustion air system or your instrument air system. So those have different design intents. So the design intent for the instrument air system could be to supply air at so and so pressure to so and so users. The users could be certain actuated valves, could be subsea valves, whatever. Just that system, that whole system. So you take that as a node, as opposed to your combustion air system. Your combustion air system is probably just taking air from the atmosphere, taking air, and then it's pressuring up that air and running it through your combustion stack. So that system is different from your instrument air system. So that will form a separate node, sort of thing. There are lots of other examples. Just quickly, we want to next one. So when there's a difference in differences in the fluid phases, you're looking, for example, at your crude oil system, liquid hydrocarbon system versus your gas processing system. Those would form different nodes within a particular process that you're looking at. That process that has up. So different fluid composition. So crude oil versus condensate versus produced water, all of these systems within a process that the HAZOP in would form different nodes. And you take them where the crude oil system, if you're dealing with the crude oil production system, take it from where it comes from the wells or the manifolds all the way to the test separator, the first stage separator, and all of that. And if it's the produced water system will be coming from the separator, say from the first stage separator to the slops tank or whatever sort of thing, where it ends up. So that will be another node. Your condensate system, will be coming from your separator to the pipeline straight into the export gas. Condensate exports pipeline and so on. So those will be those will form different nodes. So you are not able to HAZOP all of those together in one, and you've got to divvy them up into those nodes. So the other items that will form nodes are major pieces of equipment or subsystems. So for example, the compressor package, the HP flare system. So you take that as a separate node. Low pressure, the high pressure flare system, the low pressure flare system. Each of those would form a different node because they lead to different. They obviously operate at different pressures for the flare. The two flare systems I mentioned there. So that by itself, is determinant your nodes. If you got storage tanks, maybe crude oil storage tanks or diesel storage tanks, each of those, so that between the inlet pipework and the outlet pipework, you'd identify sections of those and HAZOP those as single nodes, and so on. So a piece of advice, as much as possible, your node should start and terminate at major plant isolation points. So for example, your manifold ESD valves, you identify certain plant shutdown sectioning valves as they call them. So your node should start and end at these sectioning sectioning valves as much as possible. Maybe your choke valve at your wellhead, your riser ESD valves. So you identify these sectioning points as your node, either starting or end points. Or if you're dealing with a package or a skid system, you're looking at stopping or starting your node, the battery limits of those systems. So those are just the sort of rules of thumb that you apply to selecting or identifying your nodes. The other bit to think about is that nodes that are very small. So sometimes you could decide you take a single line of your crude oil system and not include maybe you take the supply line, for your crude system or for your produced water system. Well, produced water wouldn't have a recycle. The example I want to use with that recycle, or you take your air supply line that has a recycle line back to the supply source, and you decide that you take the supply section of that line only as a node, and then the return section of that be a separate node. It's a bit of a balancing act, to decide whether to do that or not, because if you take very small sections, you might end up with a very, very lengthy HAZOP. Rather than if you combine the two nodes, both the recycle and the return line and the supply line, it's ideally better to take those as a single node. So you don't want your nodes basically to be too small, at the same time not too large and complex, because you're likely to miss out on certain things. And then you would confuse the application of the guide words as well. You're talking about more flow in what direction are you talking to, if you're considering both the supply and the return line, for example. So it confuses the application of that particular guide word in that sense. So it's a balancing act that comes with experience to get it nailed down. So here I've put, I don't know if that diagram is very visible, especially the bits on the left of that there. Okay, so that's a typical sort of a boiler package, for example, that you're looking to HAZOP. And there are various, obviously, different subsystems for that boiler package. You've got the combustion air system that I touched on. Excuse me a moment. You've got the supply, fuel supply on the left there. I'll just read out. I'm not sure if you can see those bits in the boxes very well, but those are the different subsystems for that boiler package. With the fuel return at the top there, the fuel oil supply at the bottom. So you can see that both those lines, the fuel return and the fuel supply, are colored in purple, which is one. They've taken those as one single node. So the question might be for you that, do you take the fuel return line as a node in itself, or do you take the fuel supply line, itself altogether? But here we've taken this as a single node, which makes a lot of sense. Although you would have to be watch out for when you apply for your guide words to make sure everything is taken in. You've also got the steam system and the condensate, the atomizing steam system and the condensate system being taken as one node. But the instrument air system, all the instrument air system being taken as one separate node. You've got the flash gas system, flash gas into the boiler. Being taken as one node. And what's that now? The combustion air system as well is a separate node. So typically, that's how you divvy up your nodes. All the little subsystems that feed into, or that make up part of that whole package, or boiler package in this case, are being taken as um, different nodes based on the design intent, as we mentioned earlier, because they're doing different things, intended to do different things. On the second example here we are looking at a diesel system, so diesel storage. So the two bits there are diesel storage tanks. So that those take up raw diesel. They get fed raw diesel, and then that's distributed to other subsystems. We've also got an auxiliary system where we've converted two separator vessels, defunct, separator vessels into diesel storage. So first off, your raw diesel system, the yellow lines there, the yellow bits on that PNID are being taken as one node, or the supply and return to that raw diesel system. And then the blue bits here, where this is the drains lines from the supply lines from the diesel system to via the strainers to the auxiliary supply system. Those are being taken as two separate nodes. And you would see as well that the two diesel tanks, which are separators, they are being taken as two separate nodes, being treated as two separate nodes. For this particular one, even though they do, so the outlets. So what? So the supply into that tank, which is the second separator vessel, is taken as a separate node from the discharge from both vessels to the users. So there are different ways to figure out to do your nodes, but just following those rules of thumb. As I say, there's no hard and fast rule about it. It's not that scientific. It just depends, on the method that enables you to apply the guide words correctly and try not to miss out on anything, not to allow things to fall through the cracks for those ones. Okay, that was node selection. I'll go back into presentation mode, see if we can. So now we're going to look at the HAZOP process itself. So you've selected your nodes, you've prepared for the HAZOP, you're in the HAZOP now, and what's the process that you follow? Or done, shared or done HAZOPs. The audience is very familiar. So it's instead. You record the design intent. So you take each node. So for each node, you record the design intent. I'll bring up the typical HAZOP worksheet later, but you record the design intent as well as the design and operating parameters that apply to that particular node. You apply the guide words, so no flow, more flow. So for each of those, you have to apply the entire list of guide words to that node. So that's what this is depicting, basically. So you apply the guide words or deviations in the flow. For each deviation that you have set, so you're taking temperature high, you list all the causes or all the potential causes of high temperature in that system, in that particular node. You list all of them, and then the next step 4, each of those causes that you've listed, you then list the consequences of high temperature based on the cause of what's causing the high temperature. I'm just running through this, but we'll look at worksheets, typical worksheet later. And when you've listed the consequences for that, you identify, so obviously you would evaluate those consequences. That's where the team starts to, talk what could happen. And that's where the safety engineer, for example, contributes as to what the ultimate, mitigated consequences are, because that's what you're looking for. You're not just looking for a consequence that says there's a high temperature, the pipe work is going to be heated up above design temperature. So what then happens after that? Could it rupture the pipe work? And then if it ruptures the pipe work, what then happens? Could it lead to an explosion, or could it just be a leak, maybe a gas leak or an oil leak? So there are different obvious levels of consequences. So could it just be a flange parting? Could it be a catastrophic rupture that could result in a fire and explosion and therefore result in fatalities? So you've got to take the consequences to the ultimate, unmitigated consequence. And after treating the consequences in that manner, obviously, you then move on to say, what safeguards have we got against this? Okay, we've got temperature transmitters, we've got temperature trips that would trip at once the pipe work or the system reaches a certain temperature. We list all of those safeguards. And so this is where the chair, the facilitator now determines, are those safeguards adequate? In fact, it's the team that sort of, are those safeguards adequate? Is that one temperature or temperature trip that we've got there, is that sufficient? We need an additional temperature trip. Discussions like, could that temperature trip itself be impacted by that high temperature scenario that you're looking at? If the high temperature scenario is such that it could also take out the temperature trip by whatever mechanism, then of course it's not a valid safeguard. And so those are the sorts of discussions you have in the HAZOP, led by the facilitator. You want to make sure that your safeguards are sufficient and appropriate. So do you, for example, need an additional temperature trip that is, dissimilar design, so you avoid common cause failures, for example, so that both temperature trips are not affected. Not both temperature transmitters are not affected by that same scenario that you're looking at. Those are the sorts of discussions you look at. And then you determine, right, we need an additional dissimilar temperature trip as an example. So that goes in as a recommendation. And that's step 5. And so you've taken that node, that particular course to the end. You then repeat steps 2 to 5 for the next guide word. So you've dealt with the causes. For each of those causes, you've identified the consequences, and then you've identified the safeguards and the shortfalls in those safeguards and the actions. You go back again to the next guide word. You apply the next guide word to that process. Flow, no flow, less flow, and all that. Go through the process again. What are the causes of no flow? What are the causes of more flow, and all that? You take it all the way through the process and then cycle back again. Carry on. So that, in a nutshell, is how the HAZOP process works in terms of actual conduct of the HAZOP. Not to dwell too much on that, we'll move on to the next one, the recording. So while all of these conversations are carrying on, somebody should be recording. Ideally for me, the scribe at sitting in and recording not just recording the conversations. We'll take a few points here regarding how the recording. So first of all, the recording tools, as I mentioned earlier, it could be software-based tools, like PHA Pro, HAZOP 360, Vices, and so on. Or you can just use the box standard, Excel sheets or Word template. Each of those suffices. There's nothing wrong with any of those. So the recording process, so the scribe. So I've just put here a few do's and don'ts in terms of the recording. So as those conversations are going on, the scribe is summarizing the discussions of the team. So it's obviously not recording the entire conversation. It's not, I don't know what's it called, a copywriter or anything, or a teleprinter, but he's summarizing the discussions, understanding what the discussions are about, and then, taking a note of them and receiving, guidance sometimes alongside by the facilitator. Depending how experienced one is at scribing, you may not need that much guidance from the facilitator, but sometimes in some HAZOPs, the facilitator really has to make input in terms of what is actually recorded, what the key issues are that are recorded. But there's a point that's interesting further down the line, which we'll look at. So the scribe is also anticipating, what the conversation. So someone brings up an issue, and a good scribe is also already anticipating. Okay, so this is what this, and it's also recorded. It's already recorded. The other thing to note about recording is you are obviously projecting the recording up on the screen, and so participants at the HAZOP are looking at the screen and either saying, "Okay, that's right," or "Not right." I'm just looking at the recording as well. So things are not just being recorded in in the dark, so to speak. Scribe should also ensure the completeness of full recording. I think the next bit talks about, whether you record a HAZOP in full or you do it by exception. We'll touch on that and the reasons you might want to do either of those. So the next bit is about parking lot items. So parking lot items are maybe discussions that are not quite resolved in the HAZOP. So there's a query that someone can't quite, you can't bottom out until perhaps you've dealt with another section of another node or another section of the HAZOP that goes in the parking lot. There's a query and someone in the team or some people in the team are not able to, and they say, right, we are going to check on this and then, get back to the HAZOP team. It's not something that you take an action for, but it's something that can be quickly checked. So those are the sort of typical parking lot items. Now, the scribe's role is to ensure that those parking lot items which you are leaving, maybe you put just some gaps in the reporting, those are all sort of completed later on or incorporated in the worksheets. Now, the scribe should not choose which comments to record. So he's summarizing the discussions, anticipating the flow, and recording, but he should not decide or he or she should not say, okay, this is right or that is wrong, and I'll record this. No. So that sort of scenario is where the chair perhaps comes in and gives some guidance as to what should be recorded. If there's any sort of
Sorry, Cassie, there's some static coming from your end.
Oh, all right. Sorry, folks. Is that any better now? Is that any better? Can if you press confirm?
Here you go. I keep getting some stuff. Background noise. It's better now. Thank you.
Is it better now? Okay. Hopefully, the bits earlier. So I'm talking about the do nots, what the scribe shouldn't be doing as they are recording. The scribe should not record their own interpretation of what's been said. So that's different from summarizing the discussions and maintaining or anticipating the flow. So their own interpretation is not what's meant to be recorded. It should be what is actually discussed and agreed within during the HAZOP. And the scribe should not wait until a comment is perfect before recording. So it's better to just record it and have the team or the person who has made the comments say, right, that's fine or not fine and all that. But what is said or what is agreed is what should be recorded. So those are a few tips in terms of the recording process for the HAZOP. Obviously, there are standard worksheets that are used for recording, and we'll look at the standard. Just bring up a worksheet. I think I have it up here somewhere. So that's a standard HAZOP worksheet. So at the top there, we've got so the node description. Can we all at least see the worksheet, the headers? I mean, I don't know if we can all read the text in it, but can we just show indicate by show of hands or something that you can? So if you let me know, can you see anything on that sheet that's up now?
Yes, I can see the headers making a lot of the text, but I can see the headers.
Yes, we are basically not interested too much in the detail itself at this point. So you describe what node it is that you're looking at. So that's node 1. It says oil vaporizer heating coil between inlet and outlet isolation valves, XX and YY, etc. And you record the design intent of that node. So for that node, what is it doing? Is it an air system? So the recording here says oil enters the heating coil as a liquid, and so on and so forth. The oil is controlled by a flow control set, which includes a flow control valve, and the intent, the vaporizer oil temperature is monitored by temperature element, which controls temperature by regulating the flow of gas through the controller. The high temperature switch shuts the gas flow. So this is describing the boiler operation, which is the design intent of that whole heating system.
I see you're breaking off. Is it only on my end?
No, I haven't done anything different.
Okay, it's clearer now. If you can keep it at the space, that would be
Okay.
good.
Is that
Okay.
better now? Is it
Yeah.
better? Because
Yes.
what I've done is I've taken off my headset and I'm just speaking with the computer audio now.
Yeah.
So hopefully that is better.
Yeah, that's definitely better. And considering the fact that, so that we can hear, everybody can hear you clearly. It is definitely better. Thank you.
Okay, good. We've overshot the time a bit, but we did have problems on the start. So I'm just going to, so that's the HAZOP worksheet there. I'll just go back to presentation mode and run through the rest. Caption recording. So I mentioned full recording versus recording by exception earlier on. So full recording is when you're doing the justice what you should do, which is the standard recording all the deviations, all the causes, all the consequences, and actions and safeguards and actions and recommendations. Recording by exception is where you decide that, right, you're not going to record everything you're not going to apply all the deviations. For example, you're not going to record stuff for all the deviations unless you find something, that is, you find an actual hazard. You identify an actual issue or concern that needs to be recorded. Typically, the recommended practice absolutely is full recording every time. However, there are times when, so for example, you are re-HAZOPing a system that's been HAZOPed already. So you've done a HAZOP on a system that has packaged equipment within that system, just as an example. And at the time that you've done the HAZOP, you're not able to get information, say, from the vendor, that package system. So you leave that as what we call a black box, as you might know. You leave that as a black box, and then you come to do another HAZOP of that black box. You have not gotten the vendor information, and you want to HAZOP that package itself now. Remember, you've HAZOPed the rest of the system around it. So that you can decide, right, we've done this before, let's not go through that. Let's record the exception. You're looking at the package. So for any bits of the package that, either the inlets or the outlets, we would record those by exception. We're not going to go through all the guide words. We just run through them. If we only record if we find something we need to record. So that's just next actions and recommendations, which is quite important. And the focus here for me is how those actions and recommendations should be framed. So the first bit is that they must be smart, they must be specific, they must be actions, that is, must be measurable, they must be achievable, they must be realistic. We mentioned, I think I gave an example earlier of where you are recommending that new valves be added to a system, and perhaps the project engineer is telling you the lead times for those valves is 8 weeks, 10, 12 weeks or whatever, and our project is supposed to finish in 2 weeks' time. So that's not a realistic action, for example. You need to think about things differently. Either that or back to the whole project. You just have to look at the entire project and see how achieved. And then they must be timed. The T in that smart is timed. So that's where you have a closeout date for each action. So each action must have that. And in addition to that, an action or recommendation that you put in there must be standalone, must be able to stand alone. So if someone hasn't attended that HAZOP, for example, then got assigned or got asked to close out one of the actions, any of the actions, must be able to read that action and understand fairly well what is required of them to do. Some examples in here. An action that you don't want to be framing an action. So this is an action from the HAZOP. So review the means of displacing nitrogen, potential contaminant in gas. 13.2. Even if you have been at that HAZOP and you went to that HAZOP a week ago, you might hardly be able to understand or remember what this is referring to. You want to be saying this as your, your action. So the ABC HAZOP has identified a potential concern that nitrogen could be subject to adiabatic compression, leading to very high temperatures and potential damage to the riser and topside components. In the event that the pipeline is pressurized with nitrogen, it's recommended that the risk of adiabatic compression in the pipeline is evaluated. A suitable means of displacing the gas. So if I didn't attend that HAZOP, or even if I attended that HAZOP a year ago, and I now saw this action, I think I'm fairly comfortable to understand what's required of me to close out that action. I think so. That's one thing to just keep an eye on when we are framing HAZOP actions. The next bit, I might have talked about this earlier as well, is to check that action does not itself create another hazard scenario. I'll just give you an example, which is just a follow-on from this, from the other action, the first action recommendation there. Now, apparently, there had been a prior HAZOP, a subsea HAZOP, a subsea pipeline HAZOP that had recommended that nitrogen pressurization should be considered as a means to reduce the risk of hydrate formation during startup. So you are now doing this HAZOP, and you now identify a concern, that nitrogen could be subject to adiabatic compression, leading to very high temperatures and so on. So if this second bit of the action wasn't there, and you had just the other action, it says the XX subsea pipeline HAZOP had recommended that nitrogen pressurization be considered. Now you are recommending the use of nitrogen for pressurization, but without knowing, inadvertently, you are introducing another hazard. So those are the sorts of things you want to avoid. You want to check during the HAZOP itself with the team to make sure that you're not introducing a different kind of hazard. Potentially, more likely, it's usually a reactive sort of type of hazard, chemical reactive hazard that you might be introducing by making a certain recommendation. Those are the sorts of things you should really keep an eye on the record for. Recommendations are being made as a HAZOP. As I mentioned earlier, you've got to time them, you've got to assign them to people who are. So the other bits on the HAZOP, you must track the actions and close out. I think I'm missing something here. Okay, yeah, the first sentence at the top is what I was looking for, actually. So actions must be assigned to responsible parties who are in the room. It's not advisable at all to assign actions to people who have not attended that HAZOP. For the reasons that I mentioned, in this example that I've given here in terms of how the action is framed, the person has to have been in the room to understand the full context, listen to the discussions that have gone on around that culminated in that action being raised and all that, so they would understand what's required. Even if that's, that person that it's assigned to is not the one that. So, for example, an action is assigned to process engineer who's in the room, but it's an action that has to do with the materials and corrosion, the material spec for a particular piece of pipe. It's not likely that it's the process engineer that will close that action. It's more likely that it's the materials engineer. So the business engineer, or maybe the mechanical engineer, can take that away and say, right, so I'll give this to the materials engineer and explain the context. So the materials engineer will close it. But the responsible person for that action, of course, will be the person in the room that has taken away the action. So that's another thing to look for. In terms of closing out, you've obviously got to then track those actions, and close them out. You could use any means, just a manual Excel sheet, or you could use an automated action tracking and management system. There are various kinds. There's PMIS, PIMS, and there's this other one, ATMS. I think in my previous former life, I think I have. So the automated action tracking one, so is the one that you are able to send out automated email reminders for people. So maybe the action closeout date is nearing, so you send out a reminder just by pressing a button. It sends a reminder to the persons. First of all, it sends an automated action notification, and then sends reminders until the actions are closed. They're all closed in that system. So you could use that, or you could just use the manual means where you have to go around actually sending emails to those directions. All actions must be satisfactorily closed before the commissioning or startup of the system or the plant that HAZOP was. Or so if you are between phases, so you finished the feed at the end of the feed for that design. Obviously, the design is not complete, but someone else or it's moving to another phase. What you need to do is make sure that all the actions are in what we call, I like to call known condition. Known condition in the sense that you've been progressed to a certain stage. It's very clear what is required at the end to close the action. So, for example, you have an action. Again, I'll just use the previous example that I gave about the nitrogen pressurization and that. So you want to carry out a study. So the action could be that you've carried out the study to determine whether or not the diabatic compression of nitrogen can actually occur, is credible within the operating parameters of that system. And the next bit of the action could be that yes, it is. Therefore, what is the alternative that needs to be used and how can that be implemented? So the first bit of the action might have been closed out, but the second bit has to be closed out by a separate person. So if you're between phases in the project design, you want to put that in there and state what is required. So for example, yes, nitrogen is a risk for introduce a risk of diabatic compression. Therefore, we should not be using nitrogen, we should be using so and so. However, the project team needs to make provisions for, what the alternative that could be used. You could use methanol, you could use just water, methanol, dosed water to do the flushing of the pipeline. If it's testing, testing of the pipeline, pressure testing, you decide to use just air to test the pipeline, or you could use water. You could change to hydro testing, for example, pressure testing of the pipeline. So you would have to put that as a second phase. So the action is not closed out until someone has made a provision for hydro testing the pipeline rather than using nitrogen, for example. So all of that must be put in. So that is the known condition that we are talking about. So after all of that is done, actions are closed out. So you issue the HAZOP closeout report, which must obviously have the fully signed up action sheets. Or if it's between phases, you have the action closeout status, stating what actions are closed and what actions are outstanding. So that the next person, the next entity, in fact, it could be a different company entirely during the next phase of the project. So we know how to pick things up from. Any post-HAZOP findings. So sometimes in a HAZOP, you finish the HAZOP and maybe say, or if in fact a HAZOP participant remembers something or finds out something. So that again is discussed with the chair and other members, and if it's agreed, that has to go in the closeout report as well. So this is what we found. The HAZOP report, the final report should have a statement by the chairman to say that all the actions are satisfactorily closed and that the design is fit for purpose. So typically, I like to have that statement in there. Maybe it's just me. Right. I had a final exercise here. I don't know if we've got time to do that. I am minded to skip this exercise just because of time. I'm sure I can. I'm aware that people are.
That's fine. If you can just carry on without the exercise, we do have a few questions, and I would like us to be able to address those questions.
Exactly.
Thank you.
That's what I thought about. So if it's all right, I'll skip over this exercise. But basically, I just wanted to show you what poor recording and good recording looks like. Yeah. Right. I'll just wrap up now, and we can go to the questions. So we've said that a HAZOP is a relatively onerous undertaking. Check that it's what you require before you actually start. And that's the way we HAZOP decision matrix and other triggers for a HAZOP. So try to limit attendees to only the required personnel. You want a team that is sizable, that can be focused, and easily managed. So, productivity. you want to ensure that the design for the HAZOP is at a sufficient level of completion before HAZOPing. And I have been in more than one HAZOP, more than two HAZOPs where the HAZOP has been completed because there's too many question marks around the design, even down to certain design parameters. So at that stage, you could get a HAZOP just for that. So make sure that things, P&IDs are issued to the revisions or for design or the revision that is right. In terms of participating in the HAZOP, I'll say here that, you see, this is directed at perhaps the less experienced among us who have not been to or done so many HAZOPs. So speak up if you have the slightest concern, because that thing that you wanted to say that you think might be something stupid or not clever, or that make you, it could trigger a thought in someone else more experienced. Touched on something you're not quite sure of yourself, or you've just got something or someone's something clicks in someone else just picks it up. Then it expands into something quite significant. Sounds I've seen it happen a few times. So by all means, don't be shy to speak up, no matter how insignificant you think something. Finally, a HAZOP is a critical design and operational plant document for future reference. On that, so ensure that the quality of both the reports and the closeout of the actions, can stand the test of time. If something happens, there's a process safety incident, the HAZOP is the go-to, document. So you want it to be able to stand in position almost. And obviously, if there's any other even operability problem from with the plant, you want to be able to reference the HAZOP and get some kind of direction, direction from the HAZOP. So the quality has to be there. On that note, ladies and gents, quality wrap. I hope it's been useful. Happy to take all those questions. I'm telling you.
Thank you very much, Cassie. Thank you, everyone. And once again, we do apologize for the rather slight overrun. And there are just a few questions, and we would appreciate if you could stay on and we can quickly breeze through the questions. And at the very end, I would put up the poll. Hopefully, it will work this time around for a survey and just quickly run through some of the events we have coming up with AFB in AFB in general. Cassie, at the beginning of the poll, I had somebody say that, well, basically they've worked with HAZOP before, but kind of like the options for the poll were not quite fitting with their own answers. Just for the questions now, they said, Olalekon asked, who can perform a HAZOP and what does it take to have a safety process engineer? What does it take to be a safety process engineer or consultant?
Okay. Was it typed? I was just looking for that.
It was typed. So who can perform a HAZOP to start with? And the next question is, what does it take to be a safety process engineer or a consultant?
Okay, that's fine. Good question. So I was tempted to say anybody can perform a HAZOP, but obviously you've got to have some training. You've got your academic background to have. Even though I mentioned at the start, my first degree was in civil engineering. I subsequently, did safety engineering and risk management, for example, where also things like HAZOP. And then, I underwent a lot of other, training. For example, I am an ICMA certified HAZOP chair. I did that 3 years ago. So it's those sorts of things that you need to have done to qualify to chair a HAZOP. Obviously, experience as an engineer is key. You can't just come up with maybe you're an arts an art background, do the courses that I say you've done that I've done, and then you need to have the engineering background to back up, to understand things, maybe process or chemical engineering, or even mechanical engineering. Physical sciences, basically, I should say, experience on that. So that your background experience from specific HAZOP training, such as the ICME, certification, or any other sort of, even the ABB one, I did attend the HAZOP, leadership roles, maybe quite a few years ago as well. So you need to have done all of those things to be able to chair a HAZOP. And the second part of that question, what does it take to become a safety and risk engineer or consultant? I'll again use myself as an example because I am one. So you have done a degree in the physical sciences, or engineering. Basically, that would be the background. And then you have to have done something more specific. In my case, I did a master's degree in safety engineering and risk management and reliability. You need to have done that stuff. Even without that, if you haven't done that additional degree, for example, you need to have worked as a safety. You need to then work as a safety engineer using your engineering or physical science background as a starting point, and you gather the experience on the job as you go, even without having done a specific degree in safety engineering. But ideally, after some time, you still want to do it so that you understand things a bit better. So that's what it takes, in my view, to become a safety engineering, a safety engineer or a safety engineering consultant.
Okay, thank you very much. There's still kind of like, for my end, there's still kind of like a bit of static, like, coming intermittently. I'm hoping that everyone else is not experiencing that. Another question, is this HAZOP decision matrix procedure, is it same for all the organization?
Good question.
Mm-hmm.
So different organizations design their own basis for determining whether to do a HAZOP or not. So
okay.
the one that I've shown you is one example from what are used in one organization. Another organization might have something different, but the aim, the objective of it would usually end up being the same thing. There might be slight tweaks, but mostly in the administrative bits of that form, in terms of how it is structured and who does what. But in terms of the actual technical content, I don't think it will differ very much if the aim is to be achieved. So yes, different organizations would have their own different mechanisms for determining whether to do a HAZOP or not. And they will have that in their HAZOP standards, in their HAZOP procedures.
Okay, thank you very much. I'm just going to go through the next question now. How big should the valve be for them to be an HAZOP? The particular size the valve has to be?
Oh yeah, that was Abdulaziz's question. Okay, good. Well, it's not so much the size of the valve in my view. It's so that bit about mechanical packages. It's just that equipment. So a valve, no matter the size, is still classed as we class it as pipe work, basically. It could be unless it's even if it's an actuated valve, it's just valve. If it's an actuated valve, then it has some instrumentation and air supply for that actuated valve. Typically, it doesn't change the fact that it's a valve. It's part of the pipe work, as we term it. It's part of the valving. So the size of the valve itself doesn't determine the HAZOP. So it's the parameters, the process parameters, and whether or not you have a standalone equipment package. That's what that was referring to. So it's not so much the size of the valve.
Oh, okay, thank you very much. Another question, actually, I think this is the last question we have. It said, why is it that after performing an HAZOP, we still have an ETC, we still have accidents or incident occurring? Could you shed a bit more light on that?
Yes. No matter how many HAZOPs you have, you have the Swiss cheese model of how accidents materialize. Whose question was that, by the way?
That was by Olalekan.
Okay, yeah, Lekon. So I don't know if you're a safety engineer or you work in the industry, but you might have heard of the Swiss cheese model of how accidents come about. There are different barriers that need to be compromised for accidents to occur. Now, performing a HAZOP and closing out and doing all of it is just one of those barriers that sit on the period. Not so much. It's not a barrier in itself. It's a design activity. It's a design activity. There are so many barriers that the HAZOP comes up with. That's it on the preventative side, which is the barriers that prevent the accident happening. Any one of those barriers could be compromised. So you could have done your HAZOP and provided for shut-off valves to be. If one of those shut-off valves gets compromised, even one of them during the operational phase of the plant, then your HAZOP doesn't count for anything. If that valve is not maintained properly, for example, or inspected to then check and change out when it's not working properly, and so on. Your pipe work, if it's not inspected, if there's no fire detection, gas detection or the fire detection is not working or is not spec'd properly. Well, those are the subsequent barriers that could prevent an accident happening or even control an accident. So it's not the HAZOP itself that does all of that. There are other barriers, the other pieces of the cheese, pieces of cheese in the model that could fail to cause an accident to happen. So yes, you could still have an accident after a HAZOP. The HAZOP in itself does not take care of everything, because that will be operated by persons of varying competence.
Okay, thank you very much, Cassie. Just to check, is your screen still sharing? Because I'm getting that the common events I'm putting up is still looking blurred. If you are still sharing your screen, could you please stop sharing your screen? If can you all see the upcoming events? I'm just going to quickly run through it. We have definitely overshot everything, and just so that you can know what kind of events we have going on. Bear with me. So coming up next will be the Transition Careers event. That's from the Next Gen, and that's taking place on Tuesday, 7th of October. All the details of this, by the way, will be on the AFP UK website, and they'll be for you to be able to register. You will have to register through an Eventbrite, and then the link to the Zoom session will be sent to you later, and that's just for security purposes. The next Real Projects event that is coming up is this Wednesday, and we have Jonathan, who's going to be talking to us about modeling the unknown and ensemble modeling approach for the prediction and the management of marker blowdown performance. It promises to be a very interesting one, so do sign up. We also have another one from Next Gen, which is the CFD and the wind engineering. This is targeted at age 9 to 16 years old. So, the whole idea of Next Gen is to get people interested in the STEM careers. So if you have a young one, sisters, brothers, cousins, children, please get them to sign up. Also, we have this is from the leadership session, there'll be the Embracing Inclusion and Diversity on Progressing Towards Leadership. Roy will be hosting that, and that is taking place on the 4th of November. As I did say, all the events are on the website, so you can, register. When we're all active on all the social media platforms, so do like, do share, do register for our events, and just keep the conversations going. Also, we have the 2020 Diversity and Inclusion Awards. I'm not quite sure if Oli has an update on that, but that's it from my end. And thank you all very much for joining in. Thank you all for staying this long, even with the hiccups and everything. And lastly, I'm just going to pull the poll up and just see if you've been able to if you can't even get on the poll, just let us know. Has this been useful in any way? If you have any comments, any questions, please kindly send to us, because we always want to improve on things and just how we're performing, basically. Bear with me, I do have a few more. Okay. The certification participants will be issued. Okay, yeah. Actually, we're working through the process of being able so that you can get some sort of certificate to say you've done this as a CPD, because we all know we have continuous professional developments, that we're working towards. So we are working on it, and for future events and everything, you would have a certificate of participation. Also, you can contact us, because I usually do a CPD lock and I put details and a contact. You can always contact AFB just to confirm if whatever body you're presenting to is wants, further verification. I'm sure we're able to arrange that for you. So if any other questions, comments or anything, feel free to send through, and I will pop my there so that anybody can email me. And there's also Rina, please can you help me pop the email for AFP as well there? So if anybody wants to have any questions or any follow-on conversations, on this. And thank you all very much for joining in. We do appreciate your time.